All right, welcome to pre-calculus. We're gonna go ahead and finish 6.1 today. I'm gonna try to do this every day, but on your homework on the bottom, you don't have to answer. If you don't care, I don't care either, just to keep you guys entertained. I have this book of 3,000 questions. I'll put this on the homework assignment and you can answer it your own way. I'll have the actual question down here so it won't waste any more of my time, but I'll have that there. Again, you don't have to write to it. It's just to keep you busy, for me to get to know you a little bit more and for you guys to respond a little bit more. Okay, so for 6.1, it's angle measurements. We have a lot of formulas here. These formulas are on your book, so you don't have to, screenshot every part of this video. Here, we have the length of an arc. We have a circle, we have an angle inside. The length of an arc is that outside portion right there. So it's S is equal to R times theta. S is your length, R is your radius, theta is your measurement in radians. Everything in here, it has to be in radian form. So now, let's go ahead and find our missing one. Also, if you have your length and your radius, but you don't have your measurement, here's the equation. That theta is equal to S divided by R. So it's a length divided by the radius. So example 4, it has it in, the book has the problem. I just have it shortened here. What is the length if the radius is 10 and the measurement is 30? Before we even begin to plug it into our equation, which is R times theta, we have to convert this to radians. To convert to radians, it's 30 times radians over 180. And that's how you can convert it to radians. So when I do that, I have S is equal to radius, which is 10, times your theta, 30 times pi over 180. Think of 30 times 1 over 180 like a fraction, and then simplify that fraction, and you get radians over, radians over 6. I was looking at 3. After that, you multiply across, you get 10 radians over 6, and that can be simplified to 5 radians over 3 meters. That's the length of that arc. Now, the next one is, what is theta if the radius is 4 and the length is 6 meters? So that means we have to find theta. So it's S, the length, divided by the radius. So we have both. So it's 6 divided by 4. This can be simplified to 3 over 2. The measurement is 3 over 2 radians. It doesn't have the pi symbol, but it's okay because every number from this lesson and so on is in terms of radians. If I were you in your calculator, I would put it in radian form. Again, that's right here on the top. So degree, and it says degree, and then you choose radians. Next one, area of a sector. So to find the area, it's 1/2 times radius squared times your measurement in radians. Example 5. What is the area if your measurement is 60 degrees and your radius is 3 meters? Here, before I begin plugging it in, I have to go ahead and convert this. So I know I do a radians divided by 180. And 60 times, think of 60 times 1 over 180. You get a fraction, simplify that fraction, and you end up with, I have that right here, radians over 3. 60 over 180, simplify that as a fraction, and that's 1 over 3, and always include the radians on top. So here, it's area is equal to 1/2 times your radius squared, 3 squared, times your measurement, which is radians over 3. Now, you go ahead and multiply. I get 1/2 times 9 times radians over 3. Think of 1/2 times 9 times 1/3 and include that radians on top. And if you do that, you get 3 radians over 2. And your area is in terms of meter. This one was in terms of the length, so it's also meters. But B is different from A and example 5. Because here we're trying to look for a measurement, especially here, we're not dealing with degrees anymore, we're dealing with radians, so you have to label as radians. And here, you just have to find the correct label. On your homework, I'd rather you just write the number, you don't have to write the unit measure there. All right, the last part is the different types of speed. They have word problems. There's the angular speed and the linear speed. Linear speed is what you deal with a lot of times in basic math. Angular, when you're throwing it across at a directory at a certain angle, that's where this comes to hand. Here, W, it's W, which is a speed, is equal to your measurement divided by your time. Then your linear speed is equal to your length of the arc. So that means you're using the equation from the beginning, S, which is radius times theta divided by your time. Here, example 6, we can go ahead and find this in 2 ways. I'm not going to read the problem, but if you look at your book, this is example 6. We can solve this 2 different ways. So the boy is rotating a stone at 3 feet long, and 3 feet long at the rate of 15 revolutions every 10 seconds. Revolution meaning 1 revolution. When you spin it once, that's 1 revolution. So that is considered a whole unit circle. We're not dealing with degrees anymore. We're dealing with actual radians. So a whole circle is 2 radians. Here, this person spun that slingshot 15 times around. So what we do is we do 15 times the whole unit circle, and this will give us 30 radians. So each revolution is 2 radians. Now here, 10 seconds, that is considered the time. So if we look at this first equation, we're going to find both of them, the angular speed. So what is the angular speed to this? We don't have what our speed is. We have our measurement, which is 30 radians. And we have our time, which is 10 seconds. And then you have 30 radians over 10 seconds. You can simplify that. 30 over 10, that is equal to 3 pi, and in this case it will be radians over seconds. So that is considered your angular speed. Again, you're not going to label the measurement there, so 3 radians is good enough for your homework. The next one here, we have the linear speed. Before we go ahead and use this formula, we have to find what S is. S is considered radius times your theta here. Your radius, if you notice the slingshot that the person had, it's considered 3 feet long. If you're spinning that around, that's considered your radius because it's the same distance all around. So that means it's going to be 3 times your measurement. Here, your measurement is going to be 15 here. Sorry, the 30, because it's the same example problem. I was looking at it wrong. It's the same example problem as 15 revolutions, but we spun it 15 times. Every time around is a circle, so it's 30 radians. So our measurement here is considered 30 radians. Now, we go ahead and multiply that, and you get 90 radians. Here we have to find the linear speed. So now we have what S is. S is considered 90 radians divided by your time, which is 10 seconds. So you simplify that even more, and you get 9 radians. And this was in terms of feet per second. Well, again, it will just be 9 radians, and this will be 3 radians. So for your linear, you're going to do the extra work of finding what your S actually is. The last one, example 7, is where it gets a little bit tricky because now it's a combination of angular and linear speed. So the equation there is V is equal to R times W. R is your radius. W is you consider your angular speed. Here, according to the problem, again, I'm going to kind of summarize it. We have a diameter. That's the diameter, 26. We have 125 revolutions. So that's being, spun around 125 times. That means 125 times 2 pi, and you get 250, sorry, not pi, radians. So your answer here for your revolutions, your angle is 250 radians. Here it says per minute. That means considered 1 minute. And your diameter is right here, but we don't have anything in terms of diameter for the whole equation. So half of that is 13 inches. The whole problem, it's asking us what is the miles per hour of the whole thing. We know the equation is V is equal to R, the radius, times W. We have a radius, that is 13. W we have to find. If we go back to the angular speed, W is equal to the measurement divided by the time. We have our measurement. Our measurement is 250 radians. We divide that by our time. Our time is just considered per minute, so that's just 1 minute. So that means your answer would be 250 radians per minute. But the whole number is 250 right there. So now we have 13 times 250 radians. For this step, I would recommend you multiplying it out. 13 inches radians per minute. I'm going to put the measurement there. And when you multiply the 2 out, you get 10,210.2 inches per minute. Radius is in inches, your time was in minutes, so inches per minute, but they're asking you for miles per hour. So right after you find this, here I had to multiply the radians out. But you have to multiply that radians out, so 250 times the pi symbol. Make sure your calculator's in radians form, or it's going to give you a different answer. Now, from this point, we have to start converting. 10,210.2 inches per minute, that's 1 minute. We have to convert inches to miles. So if I go ahead and do inches to feet, 12 inches and 1 feet, and then feet to mile. 1 mile equals 5,280 feet. This cancels out with, sorry, this is minute. Inches, feet, we have mile here. Now we have to convert minute to hour, so that means minute, make sure you're doing it across, minute on top, hour on the bottom, 60 minutes equals 1 hour. Now this cancels out with this. And you multiply everything on the top. When you multiply everything on the top, you get 612,612 miles. And then the denominator, multiply this by 12, and you get 63,360. And this is in terms of hour. You have that, simplify even more, and you end up with 9.6 miles per hour. So we had to deal with the conversion factor of it. For this lesson, just understand what they're asking you for. Keep in mind of the revolutions, how many times it's being spun around, and diameter. The key thing we're using is radius. If you have any more questions, make sure you go down to the drop box. Have a good day.